Taylor's theorem. With the Lagranges and Cauchy forms of reminders. Cauchy form of reminders. Are you able to see all of you?
Yes, sir.
Thank you.
Yes, sir.
No reminders. Cauchy forms of reminders. So concepts. Definitions. So the function could be approximated by the function could be approximated by a Taylor's polynomial. Taylor's polynomial. The remainder term Rn. The remainder term Rn. In the Taylor's theorem. Taylor's theorem. This theorem is most important for 20 marks, section C. Taylor's theorem could be used estimate the error of approximation. Next, we'll discuss Taylor's theorem. Most important theorem. Taylor's theorem. If function f, a to b to r is such that first condition f of n minus 1 is continuous. CTS means continuous in closed interval a comma b. Second one is f of n minus 1 is derivable. Closed interval a comma b. That is f of n is exists in. That means f of n is exists. F of n is exists in a comma b. And p is positive integer. P is positive integer. And 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 p is positive integer. B is positive integer. B is positive integer. Then there exists a point. Then there exists a point C such that C belongs to comma B. Means the value of C lies between A and B. Value of A lies between A and B such that f of B equal to f of A plus B minus A whole divided by 1 factorial into f dash A plus B minus A whole square divided by 2 factorial into f double dash A plus B minus A whole cube divided by 3 factorial into f triple dash A such that so on, B minus A whole power n divided by n minus 1 factorial f of n minus 1 to A plus Rn. Here Rn is the remainder where Rn equals to B minus A whole power P, B minus A whole power P, B minus C whole power n minus P, f of nc whole divided by P into n minus 1 factorial. Okay. Then proof of this theorem. Proof is define a function. Define a function phi. Define a function phi. Define a function phi a comma b. A comma b tends to R by phi of x. That equal to f of b minus f of x minus b minus x whole divided by b minus 1 factorial into f dash x plus b minus x whole square divided by 2 factorial into f double dash x f double dash x plus so on b minus x whole power n minus 1 whole divided by n minus 1 factorial f of n minus 1 x minus a into b minus x whole divided by b minus a whole power n. So a is a chosen such that phi of a equal to 0. Here a is chosen such that phi of a equal to 0, phi of a equal to 0. So f of n minus 1 is continuous. F of n minus 1 is continuous, on a comma b, on a comma b, on a comma b, and derivable in open interval a comma b. Now that implies f comma f dash comma f double dash comma f triple dash so on f of n minus 1 are all continuous on continuous continuous on all continuous on a comma b. All continuous on a comma b and derivable on it and derivable in open interval a comma b. Open interval a comma b. Also is continuous. Also b minus x whole divided by b minus a whole power p. So this is not p, this is p whole power p. Whole power p is continuous. Is continuous. CTS means continuous in closed interval a comma b and derivable in open interval a comma b. Open interval a comma b. For each positive integer p, for each positive integer p, each positive integer p such that phi of b equal to 0. Phi of b equal to 0. Thus function phi is, fn means function, phi is such that phi is continuous, phi is derivable, first condition, phi is continuous. CTS means continuous, phi is continuous in closed interval a comma b. Second one is phi is derivable in open interval a comma b, such that third condition phi of a equal to phi of b, next phi of a equal to phi of b. By Rolle's theorem, there exists a C-graph. By Rolle's theorem, by Rolle's theorem, there exists a least point, there exists a point such that C belongs to a comma b, such that phi dash of C equal to 0. That implies phi of a equal to 0. So f of b, here f of b minus f of a minus b minus a by 1 factor into f dash a minus b minus a whole square divided by 2 factorial into f double dash a, f double dash a minus so on b minus a, yes, b minus a whole power n minus 1 by n minus 1 factorial into f of n minus 1 a minus a that equal to 0. Equation number 2. Equation number 2. What is the equation number 1? Back. This is the equation number 1. Equation number 1. This is the equation number 2. Equation number 2. Right. So now phi dash of x. Phi dash of x. Phi dash of x. That equal to minus f dash x. Minus f dash x. Minus of minus f dash x plus b minus x into f double dash x minus b minus x f double dash x plus b minus x whole square divided by b factorial 2 factorial into f triple dash x so on minus of minus b minus x whole power n minus 2 whole divided by n minus 2 factorial f of n minus 1 x plus b minus x whole power n minus 1 whole divided by n minus 1 factorial f of nx plus ap whole divided by b minus a whole power p that equal to into b minus x whole power r p minus 1. This is p minus 1. The second term of each bracket cancels with the first term successively. So on simplification, we obtain phi dash of x equal to minus b minus x whole power n minus 1 whole divided by n minus 1 factorial into f of n x plus p into a b minus x whole power p minus 1 whole divided by b minus a whole power p. So therefore phi dash is equal to 0. Therefore phi dash c equal to 0. Phi dash is equal to 0. That implies a equal to b minus a whole power p or b minus c whole power n minus p into fnc whole divided by p into n minus 1 factorial on substituting this value into this value in equation number 2. We obtain we obtain f of b, that equal to f of a plus b minus a, whole power b minus a by 1 factorial into f dash a, plus b minus a whole square divided by 2 factorial into f double dash a plus so on, plus b minus a, so on, b minus a whole power n minus 1 by n minus 1 factorial into f of n minus 1 of x plus b minus a, whole power p, that equal to b minus c, whole power n minus p into fnc whole divided by p into n minus 1 factorial, Next, note. The remainder r power n is given. The remainder r power rn is given by rn equal to b minus a whole power p into b minus c whole power n minus p into fnc whole divided by p into n minus 1 factorial, is called Skoll machine. SCHLOMILCHE. Skoll machine. Rochi. Form of remainder. Skoll machine. Rochi. Form of remainder. Rochi form of remainder. Next. So by putting p equal to n, by putting p equal to n, we get Lagrange form of remainder. Lagrange form of remainder. Lagrange form of remainder. So Rn equal to b minus a whole power n fn of c whole divided by n factorial. Right? By putting p equal to 1, we get Cauchy form of remainder equal to 1. We get Cauchy form of remainder. Cauchy form of remainder. Then Rn equal to b minus a into b minus c whole power n minus 1 fnc whole divided by n minus 1 factorial. So n minus 1 factorial. So most important theorem for section C, 20 marks. The question asking Style is state and prove Taylor's theorem. Huh? Taylor's theorem. So from Taylor's theorem, only we will get Maclaurin's form. Maclaurin's form. This is this theorem. Maclaurin's form of equation number 1 is the Maclaurin's form of. This is alternate form of data. Alternate form, no need. So this is Maclaurin's form of remainder. No? So Maclaurin's theorem with the Skolnishi form of remainder. So Maclaurin's form is theorem. Second theorem. Maclaurin's theorem with Skolnishi form of remainder. Skolnishi form of remainder. Skolnishi form of. So Maclaurin's theorem with Skolnishi, Maclaurin's. And we see L U-R-I-N-S. Maclaurin's theorem. Theorem. With the Skolnishi. With the Skolnishi. Ricci form of remainder. Ricci form of remainder. Ricci form of remainder. A function f is defined. If a function f is defined on 0, x, on 0, x, such that f first one is f of n minus 1 is continuous. CTS means continuous in closed interval a comma b. Second one is f of n minus 1 is f of n minus 1 is derivable on open interval 0, x. Open interval 0, x. So, and p is a positive integer. And p is a positive integer. And p is a positive integer. Positive integer. Then there exists theta belongs to 0, 1. Theta belongs to 0, 1 such that f of x that equal to f of 0 plus x by 1 factorial into f dash 0 plus x square by 2 factorial into f double dash 0 plus so on plus x power n minus 1 whole divided by n minus 1 factorial f of n minus 1 to 0 plus x power n 1 minus theta whole power n minus p whole divided by p into n minus 1 factorial f n theta x. The value of theta is lies between 0 and 1. That means proof. Put A equal to 0. Put A equal to 0 and B equal to X. B equal to X and C equal to theta X. C equal to theta X. Theta X. For some, for all, now theta belongs to 0, comma 1. The value of theta is lies between 0 and 1. That meaning. So in Taylor's theorem, Taylor's theorem, we obtain, we obtain, we obtain, we obtain Maclaurin's theorem. Then we obtain Maclaurin's theorem. Maclaurin's theorem. Maclaurin's theorem. On putting P equal to N, putting P equal to N. In Skolmishi-Rocci form of remainder, in Skolmishi form of remainder, Skolmishi form of remainder, Skolmishi form of remainder, Skolmishi form of remainder. We get Lagrange form of remainder. We get Lagrange form of remainder. Form of remainder. Lagrange form of remainder. So Rn equal to, that means Rn x power n divided by n factorial into f of n theta x. I'm putting p equal to 1. I'm putting p equal to 1. Putting p equal to 1. In Skolmishi-Rocci form of, in Skolmishi-Rocci form of remainder. Rocci form of remainder. Rocci form of remainder. Skolmishi-Rocci form of remainder. Then we obtain Rn equal to Cauchy form of remainder. Rn is x power n into 1 minus theta whole power n minus 1 whole divided by n minus 1 factorial into f of n theta x. This is called Cauchy form of Skolmishi form of remainder. We get Cauchy form of remainder. CAU, Cauchy form of remainder. Cauchy form of Cauchy form. Hence proved. Okay, state and prove the Taylor's theorem. And note also you need to write for 20 marks. Suppose sometimes they will ask with 10 marks also. This Maclaurin's theorem is 10 marks. Based upon this result we use, we have to solve the problem. So Maclaurin's theorem 10 marks question. Taylor's theorem is 20 marks question. Okay, all of you understood?
Sorry.
Okay, this is 10 marks based upon Maclaurin's theorem. Taylor's theorem is 20 marks for section C. Objective they deleted.
Okay, sir.
Okay, thank you very much.
Okay, sir.
class is over or what?